Hello everyone, and welcome back to Physics with Mitchell. Let's take a look at our problem. The figure below shows a Ferris wheel that rotates 4 times each minute. It carries each car around a circle of a diameter of 17 meters. Let's look at our first two questions. What force, magnitude, and direction does the seat exert on a 46 kilogram child when the rider is halfway between the top and the bottom? So where do we start with this problem? First, let's start conceptually. As you can see, they already provided our two free body force diagrams. So over here I replicated them, and then I added a third, making the diagram of what the force is on the car and at the middle. Like the others, you have the normal force, you have the gravitational force, but this time you also have static friction because it's keeping the rider on the seat and its centripetal acceleration inwards. Next, let's look at our givens. For our givens, we have the mass, we have the radius, and our unknown is velocity. But with the information provided, we can find velocity. First, we're going to start by calculating the period. The period is how long it takes for how many revolutions, time per revolution. As you can see right here, time over revolutions, we know it's per minute, so 60 seconds, and we know it's 4 revolutions per minute, so we can do 60 over 4 equals the period of 15 seconds per revolution. From there, we can plug it into the velocity equation. V equals 2 pi r over period, where r is our radius. And from there, we plug in period, and we plug in the radius of 17 to get a velocity of 7.12 meters per second. Our next step is to develop the mathematical model for the x and y direction of our free body force diagram. So, if we take a look over here, we can say that the net force in the x direction is equal to mass times centripetal acceleration. And we can replace centripetal acceleration with the quantity v squared over r. So then we can say net force in the x direction is equal to mass times v squared over r. And since the only force in the x direction is static friction, we can say static friction is equal to mass times v squared over r. Next, let's take a look at our y direction. We know Fn minus Fg is equal to 0. So we can rewrite that as Fn is equal to Fg. And we know that Fg is equal to mg, which will come in later when we're using substitution. So what do we do now? Well, we have x, we have y, so we're going to Pythagorate to find the total net force. So for our equation, we have F net squared equals Fs squared plus Fg squared, because we know our y force is equal to Fg, and we know that x net is equal to Fs. So we're going to replace Fs with the equation we did above, Fs equals mv squared over r, and we're going to replace Fg with mg. And then both of those quantities will be squared, as in a squared plus b squared equals c squared. To get rid of the square on the net force, we're going to square root each side. From there, all that's left is to plug in the given numbers. We plug in the weight, our found velocity, our radius, and then we're going to plug in our weight again and the quantity g. Then from there you do the algebra of multiplication, division, and squaring until you get here, and then you square both those quantities and add them together. Finally, you take the square root of that quantity and you get your F net. In this case, the F net is equal to 456 newtons. Next, we're going to take a look at how to find the direction, or theta. Whenever we're trying to find theta, we're most commonly going to use the inverse tangent. But how do we find what goes inside the parentheses? Well, let's draw a little triangle here. So we know that our y value should be Fg, and our x value should be Fs. So, and we know tan is the same as SOHCAHTOA, opposite over adjacent, so FG over FS. And for those, we just replace them with the substitutions we used from part A. Next, we can simplify the equation within the parentheses by dividing out mass and multiplying r to get it into the numerator. Finally, we have inverse tan of g times r over v squared. From there, we can plug in the value of g, we can plug in the radius, we can plug in v and then square. And then once we simplify by multiplying and squaring, we can take the inverse tangent. But let's take a look up here. If you notice, it says measured inward from the vertical. So our vertical would be up here, and we're measuring inwards. So we're going to take 90 degrees, which we're going to take 90 degrees, and we are going to subtract it by this theta to get the true theta that the person's seat is at. So then once we go up here, we could see that this looks about right, where it's 8.65 degrees, so we could test it a little bit, and then that's our answer. So now let's talk overall. We found our answer for part A, we found our answer for part B. But what did we learn from this? Well, number one, we learned how to complete more complicated problem solving. At least for me, I personally learned a lot about substitution this time around. For example, we didn't know what periods were, we didn't know how to find the velocity, so we found the period, then we substituted it into the velocity equation. We know what the centripetal acceleration is, substituted it into the force equations. So overall, there are multiple step substitutions that can get pretty complicated. But the repetition, like problems like these, it's helped me to get better at learning when to substitute and what I can substitute to help me complete these problems. Thank you.